So hello everyone, welcome to Try Right. This is Pack 365, myself Sujit. So today we are going to learn some new coding question that might be asked you in your interview. So guys, this is the last coding section for this loop and all. Whenever we are going to implement our function, there also we are going to implement some coding question. Okay. So the first question for this session will be write a program to convert a integer into binary number. So guys, hope everyone know how to find binary. Means in the session also, whenever we are discussing about operator, I have already shared you that knowledge. Again, I just want to explain. Okay, if I'm taking a 7 number, okay, here I am taking 7 as my input. So how to find this binary number? So here first you need to take 7 is my input. Okay, 7. Then binary for every time you need to divide it by into 2. Okay, so 2 3 times 2, if you are multiplying into 3 times 2, it becoming 6 and the remaining value will be 1. Again you need to divide it by 2, and here if you see here it will be taking 1 time, so it will be give me the output as my 1. So 2 1 time and the remainder value will be becoming 1. So if you see the last 3 digit, but every time you need to go from down to up. So for the 7, my binary number, okay, if I want to find the binary number of 7, so 7 binary number will be 111. So now we want to implement this logic in our coding. Okay, guys, just see here, every time we need to take this. Okay, every time first we need to divide it into 2 and we need to get the last digit. Then what is the requirement? Okay, if I'm taking 7, okay, first if I multiply into 2, okay, if I'm multiplying into 2, what is my output? Based on that, we are going to see now. Okay, I want to give you each and everything. Okay, if I am going to take 7 by 2. If I'm running this, so it will be give me a number called my reminder value. Okay, because every time modulus will be give me the value as my reminder. Why I am telling this question? Because I need to explain you every time. Okay, so make sure that you need to find. Okay, otherwise I can explain you that you need to divide and find the remainder. Okay, so here it will be give me 1. But guys, every time if you see, we are going to some top to up, sorry, bottom to up. So here that's why we are taking a sum value, because we need to take this number. That's why we need a sum value. So the sum value will be coming 0, starting from this 0. Okay, if you see the position, I think you know this is called our first position, 10th position. This is called our 100th position. Based on that, we need to place this one. So here, after you finding, we need to multiply with this position. If we are not finding this position, it will be start creating trouble. Okay, after I am finding the remainder value divided by 2, I need to add to my position value into 1. After I am passing this position, after it will be give me my output as 1. After this, I need to update this number, guys, right? Okay, how to update this number? 7 floor division by 2. If you are giving 10, so it will be giving you the last digit. Okay, removing the last part and give the remainder. But here we need to give the floor division. That's why if I'm taking this floor division, okay, what is? Because it will be give me the quotient value. Okay, but every time it will be give me in the form of integer. If you are giving in the form of our true division, it will be given in the form of our float. If you see here, it will be give me 3. Again, I just want to take this 3 because I need to update this number 3. So I am finding this 3 here. Okay, after I am getting this 3 here, okay, I'm getting 3 here. I need to update this position. After I am finding again last digit, I need to add to my 10th position. Here I need to, every time I need to increase my position into 10 10. If I'm taking my first position 1, so 1 into 10 becoming 10. Again, after this 10, if as of now I have only 3 input, if I have the large number if I'm taking 12, so it will be getting a large number. After that, if I want to taking for this 100 position, again I just want to find this 10, it will be give me 100. Again, if I'm appearing from 1000, if I'm typing, and it will be give me the 1000 as my output. Okay, so this is the simple logic to find any integer of any binary number. So now we are going to implement, then only we are going to see the control flow. Okay guys, so here first we need to take the input from this user. So input, okay, enter the number. After I find here, we need to take the position from 1. If you are taking for 0, it will be giving you every time 0 position only. Because if you want to multiply with 0, the any number will be becoming 0 only. Okay. After you find, you need to take a sum. You need to add that particular things, right? Sum equal to 0. Here we are using the while loop because we don't know how many time it will going to iterate. So here first I need to take the first one. So if you can know this logic, then based on that I need to take. So 7 modular division 2. So here I am using based on my 2. So after I am finding 2, so here I am getting my 3 as my output. So here I need to use every time modular division 2 because I need the remainder. After I find this remainder, I need to add to my sum. So sum into remainder, and after that, sorry, sum plus, okay, sum plus remainder. Again, I need to position because my position will be starting from 1 position, 10th position, 100 position, 1000. Oh, okay, after that, I need to update this number. If I'm using 10, then it will be give me another number. But I need to get this number. Okay, if you see here, I am taking this 3 number because again I just want to multiply with 2 only. That's why here I am taking 2. So 2 into 1, it will be becoming 3 1. So it will be giving me 1 as my output. Okay, so here if I want to again this number, I need to float division with 2. So now here I am using non-float division with 2. After that, every time I need to updating this position also. So here I am using this 10. Okay. After that, I need to print this sum because my all the binary will be stored in this number. If I'm going to run any code in here, it will be start implementing this logic and give me the output. Now, if I'm taking 7, so 111. If I'm taking a new number, okay, if I'm taking 2, it will be 01. Okay, every time it will be give you the correct output. If I'm taking 11, so if I'm taking 19, so 19 will be 1001. So this is the logic how to implement. Okay, now we are going to see the control flow. Okay, so guys, come to here, I need to erase this particular. Okay, again I need to take here. Okay, now I want a new color for this one. So as of now, we are taking the number as 7. Okay, after that, 7 greater than 0. Yeah, this correct. After that, I need to modular division with 2. So I need to store in a variable. So 7 modular division with 2, it will be give me the remainder value as my 1. Okay, after I find it to 1, I need to store in my sum value. So my sum value becoming 0. So 0 equal to 0 plus 1 into my position. As of now, my position becoming 1. So here it will be printing 1 as my output. Again, after that, I need to update my number. So number 7 floor division 2. So it will be give me the output as 3. After that, I need to update this position. As of now, my position value, okay, my position value will becoming 1 and my sum value becoming 0. So here I need to update my position. So position 1 into 10, it will be becoming 10. Okay. After that, my number will be becoming 3. So here 3 greater than 0. That is correct. Again, here I need to take the remainder. Okay. So how to take this reminder? 3 modular division with 2. So again my remainder value will be 1. After that, here I need to store in my sum. So as of now, my sum value will be getting 1. So 1 plus again 1 into, so here I need to into 10. So it will be becoming 11. Okay guys, just see. After that, we need to float update this number. So 3 float division 2. So it will be give me 1 as my output. Okay. After I find this one, here I need to update this position. So as of now, my position will be 10. So 10 into 10, 100. Means after this, I need to update to 100. So as of now, my number value will be becoming 1. So here 1 greater than 0. Yeah, 1 will be greater than 0. So then find the remainder. So how to find this remainder? Number float division. So number modular division with 2. So it will be give me 1 as my output. Again here I need to update to my sum. So as of now my sum will be 11. So 11 into 11 plus 1 into 100. So it will be becoming 101. Okay, 101. So after that, I need to update this number 1 float division 2. So it will be give me 0 as my output. After that, I need to update this position. So 100 into 10, it will be 1000. Okay. After this, my number will be greater than 0. So 0 greater than 0. So this condition becoming so false. So after this, you can find this, the logic of this, how to take a binary number, means how to convert an integer to binary number. Then the next question for this session will be, I want to convert a binary number into integer, means the opposite of this one. Okay. So write a program to convert a binary number into integer. Okay, how to do that we are going to see now. Guys, just see, if I'm taking this 7, okay, here I'm taking 7. This 7 we know I need to find this integer. So to how to do that, every time you need to start from this 2. Okay, so I need to erase this thing. Okay, so here I'm taking 1, 1, 1. We know this is this 7. Now how to find? So every time you need to multiply with 2 to the power based on the position. So as of now, the position of this one will be 2 to the power 0. Okay, this one will be 2 to the power 1. So based upon your binary value, you need to update this position. So 2 to the power 4. So how to find this one? So after you get this one, so you need to 2 to the power 2 will be 0 plus 1 will be becoming 1. Okay, 2 to the power 1 will be 2, 2 plus 1 will be 2. Okay, 2 to the power 2 will be 4. So 4 plus 1 will be 4. So 4 plus 2 plus 1, it will be give you this 7 as my output. So this is my simple logic behind to how to find a binary number into integer. So we are going to implement this code logic here. So here also I need to take the user input. Okay. So first we need to take this user input. Okay. After I am taking this user input, I need to take a power, because every time the power will be given from 0, 1, it will be increment. Every time it will be increment from 0, 1, 2. So here I need to give the starting value will be 0. Then here I need to take the result also 0. Then the while loop, because we don't know how many time it should be iterate. So while number will be greater than 0. Here also, guys, just see how to find, because I have already told you the logic. So we need to implement that logic again. But guys, here we are implementing the with 10, because we need to find the last digit. Okay, because for last digit only we need to apply. So to how to find this last logic, the number. Okay, so number modular division with 10. After you find this logic, you need to add in your result. So result plus reminder, what is the reminder value, and you need to multiply. Okay, so here you need to write into modular division 10, result equal to result plus reminder. Here you need to into 2 to the power whatever the power every time, because if you see here, every time we are taking 2 to the power 0 plus this reminder value. So here also I am applying this one. Then I need to update this one. After I am getting the last digit, I need to delete that particular things. But every time I need to update my power, so I need to update into 111, because here also I am taking 1 1 1 0 1 2. If I have a large number also, here I am taking 3. Just like that you need to implement. After every iteration will complete, you just need to print this result. Okay, now if I am taking a binary number called my 111, we have already know it will be getting me 7. If I'm taking the 10011, so it will be give me the 19. If I'm taking 10011, so it will be give me 19. So my code logic will be correct. So now we are going to implement the logic, means the iteration. Okay, so here I just want to erase all the things. Okay, so here I need to update. So I am taking a bracket. Okay, so here I need to update my code. So here I am taking this code. I need to change the color of this. Okay, yeah. So here I need to take. So guys, if you see here, first of my value will be 1, 1, 1. Okay, so now it should be checking from 1, 1, 1. Okay, as of now, my power value will be becoming 0 and my result value also becoming 0. So start from here. First condition, the first iteration while will be 1, 1, 1 greater than 0. Yeah, this is correct. After that, you need to find the remainder. So 111 modular division with 10, it will be give me 1 as my output. After that, you need to add into your result. So result value will be 0. 0 equal to 0 plus 1 into power of, means 2 power, means whatever the power value, it will be becoming 0. So it will be give me the output as my 1 as my output, because 1, 2 to the power 0 will be 0 only. Okay. After that, here we need to update this number 1 1 1 floor division 10. So it will be give me 11. After that, you need to update the power. So power will be 0 plus 1 equal to 1. So it will be becoming 1. After that, the second iteration, because my number value will be updating into 11. So 11 greater than 0. Yeah, this condition also becoming true. So I need to find the last digit. So 11 modular division with 10, it will be give me the last digit as 1. After I am finding this one, I need to add into my result. So 1 equal to 1 plus, again my remainder value will be 1. Here I need to multiply with 2 exponential with my power value, because here my power value I am updating into 1. So it will be becoming 1. So here 1 plus 1 will be becoming 2. So 2 plus 2 becoming 4. Okay. If 2 to the power 1 will be 2 and 1 plus 1 be becoming 2. So 2 to 4 only. Okay. So yeah, so here it will be taking 0 plus 1, 1. Again, I need to update this number 11 floor division 10. So here it will be give me the number as my 11 into floor, it will be giving me 1. Here I need to update this my number. My power value becoming 1, 1 plus 1 will be 1 plus equal to 1 will be 2. Okay, again I need to update 1 me, because my now my value will be, the number value will be becoming 1. So 1 greater than 0. Yeah, this condition also getting true. So I need to take the remainder. So 1 modular division with 10. So it will be give me 1 as my output. Again, as of my result value will be 5. If you see here, it will be becoming 4. 1 plus 1, 2, 2 to 4. Okay, so here 4 equal to 4 plus my remainder value will be 1. Here I need to update 2 into floor division 2. Okay, here I need to take 2 to the power 4. So yeah, here it will be becoming 7 only. 2 to the power 4. Yeah, it will be becoming 7. Okay. After, if I'm getting this 7, again I need to update this number 1 floor division 10. So it will be give me the 1 0 as my output. Again I need to update this result, sorry, power value. So power value becoming 2 plus equal to 1, it's becoming 3. Okay. After, if you see, my number will be becoming 0. So 0 greater than 0, this condition becoming false. So this is the logic to find a binary number of a integer. So this is the logic behind this. So that's all for this session. In the upcoming session, we are going to start implementing this star pattern. Okay. So thanks for watching. Try right.